f of x equals 4, x minus 1, x plus 2, x plus 3, x minus 6. And on the bottom, we've got x minus 6, x plus 1, x minus 2, x plus 5. First thing you're going to do is you're going to see x minus 6, those cancel each other out. Now, we just have to keep note of this, that's going to make a whole. In other words, x cannot equal 6. Let's go ahead and list the x-intercepts. The x-intercepts are going to be 1, -2, and -3. And the vertical asymptotes are going to be -1 to -5. So go ahead and stop right now and plot those on your graph down below. All right, so I'm going to catch up to you, and let's plot those points. So the first one, +1 is an x-intercept, -2 is an x-intercept, -3 is an x-intercept. All right. Vertical asymptotes are going to be -1, and we've also got +2, and we've also got -5. Okay. Now we have our x-intercepts listed. You have your vertical asymptotes, your whole listed, y-intercept. So the y-intercept is the y value when x is 0. So if we plug in 0 there, 4, 0 minus 1, 0 plus 2, 0 plus 3. On the bottom, 0 plus 1, 0 minus 2, 0 plus 5. So spend a second and figure out what that is. Okay, so we got 4, -1, 2, 3. On the bottom, we have 1, -2, and 5. And that's going to be, let's see, we can cancel this negative and this negative. And then now that that's a +2 in it, we can cancel those out. So on the top, we have 12, and on the bottom, we have 5. So your intercept is going to be 2.4. And now the next one, the y value when x equals infinity. So if you plug in infinity, let's go down and do it here. So we have 4x minus 1, x plus 2, x plus 3. On the bottom, we've got x plus 1, x minus 2, x plus 5. If we plug in infinity, 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 then we end up with 4 times infinity over infinity, and it'll be like an infinity cubed. Basically, this isn't being super precise, but you can kind of think of canceling those out, and you end up with 4. Now, there's a better way of doing it with long division, but we're not going to bother with that. Basically, the thing to take away is if I multiply all of these out, I end up getting x cubed with a bunch of things. On the bottom, if I multiply all of these out, I get x cubed plus something, something. This has a 4, so the 4 is going to hit that. Now, if you did long division here, it's going to be x cubed and a bunch of stuff into 4x cubed and a bunch of stuff. And that's going to be 4, and you multiply that back, and you do your whole thing, and then you're going to be 4 plus something. This is going to be an x squared something over x cubed something, something. So as x approaches infinity, that 4 will always be 4. But if you plugged infinity into this one, then you have infinity cubed on the bottom, and infinity cubed on the bottom is going to be so much bigger than the infinity on the top that this one is going to tend towards 0. And that 4 is just going to stay there. So if you did the long division, you'd see the 4. But the short answer is this. If you ever see something like 7x to the 7 over x to the 7, then you can just say as this thing approaches infinity is going to be 7, even if it's 7x to the 7 plus 1 over x to the 7, right? In this case, I can't cancel those out, really, but I can say, hey, this plus 1, that doesn't really matter that much, so we're going to ignore it, and then if I cancel those out, it's basically 7. Good enough. Okay, so this is going to have a horizontal asymptote, and it's not going to have a slant asymptote. So the horizontal asymptote is 7. So we're going to go up here to 7. I'm going to just draw this in. So this is the horizontal asymptote. So we have the battle of the asymptotes. We have some vertical asymptotes and we have some horizontal asymptotes. Now the horizontal asymptote doesn't really affect anything here. There's not really going to be a collision or any issues there. The horizontal asymptote only matters as you get to infinity and negative infinity. So let's just let it do its thing here in between these values. Once we start getting further out to the left and the right, then that horizontal asymptote is going to matter. Okay, so we got to test some values, positive or negative. So if we plug in some values here, let's go back to our equation and start testing values. So we have 4x minus 1, x plus 2, x plus 3, and on the bottom we've got x minus 6, x plus 1, x minus 2. Oh, we don't need an x plus 6. That got canceled out. We've got x plus 1, x minus 2, x plus 5. And we're going to test, let's test something to the left of negative 5. Let's try negative 10. So if we try negative 10, negative 10 minus 1 is going to be negative. Negative 10, that's going to be negative. Negative, in fact, everything is negative. And if everything is negative, then that turns into a great big positive. So this right here is going to be positive. Okay, now, because of the way this is set up, it's just going to happen that the sign is going to flip each time. Now, you can't count on that happening, but just take my word for it that it's going to happen here. So we have signs that flip each time. So what that means is right here, I've got, because it's positive, it's going to go this way, and it's going to eventually approach that line. Okay, it's going to flatten out and hit that line. But right here, it hits that vertical asymptote. Now on this side, it's negative, so I'm going to stay negative. But then after I cross this, I'm positive. But then after I cross this, I'm negative, and then I hit this asymptote. Now right here, I'm positive on this side of the asymptote. I'm positive until I get to here. And then I'm negative. And then on this side right here, I am positive. So it's positive, and then it comes and hits that asymptote. So you end up with this nice looking graph. All right, should we see how close we got? Let's go to Desmos and let's check this thing out. So on the top, we've got a 4, or did I say 7 on this one? This is y, this is y equals 4. So this line right here is 4. So it'll approach 4. Okay, let's go back to Desmos. So in Desmos, we have 4, we got parentheses, x minus 1. Then we've got x plus 2. And then we got x plus 3. And then we've got x minus 6. Oh, and that actually reminds me, we forgot something. I forgot something. I can't blame you. I forgot something in this one right here, which is our hole. And remember, we have a hole at x equals 6. So I got to go in here. At x equals 6, right here at 6, I have a hole right there. So I can't forget that hole. Okay, back to Desmos. We're going to divide that on the bottom. We've got x minus 6, and then x plus 1, and then x minus 2. And then finally, we've got x plus 5. And when you look at that, that actually looks pretty good. You can see this vertical asymptote right here. It approaches 4. Those numbers get closer and closer to 4. As I zoom way out, you can see those numbers get really, really close to 4. On this side, they get really, really close to 4. Now let's zoom in and see if we can find that hole. We had a hole at 6. Let's see what happens as I trace this to 6. Let's see if we see the hole show up. There you go. You see it? Showed up for just a second. At 6, it is exactly undefined. All right, let's take a look. This is their picture. Now let's take a look at our picture. It's pretty good. Yeah. All right. That's it for today. Hopefully you can do the last 2 questions on your homework on your own.